Guten Tag. So my name is Kyle. I'm from Newmarket, Ontario. At least that's where I live now. I moved to Canada a few years ago from the United States. And I'm just going to call myself a developer, because that's what I do, code all the time. I work for two companies, for the most part. One is my official employer, called Treefrog, located in Newmarket. And then I also work for Perfect.org, where I was the instigator and main developer for Perfect since the onset. So I am going to talk about some IoT stuff and explain why it's not the focus of the presentation. But I'm also going to tell a little story about why I'm here, how I got involved in ServerSide.swift, and in particular why I am here as opposed to somebody else from the world. I'm going to talk about Perfect, and I'm going to introduce the team and talk about what we've all contributed individually, and hopefully that will give you an idea of what Perfect has in it and what it has to offer. We're going to talk about what we use Swift servers for, and these are production applications, microservices that we've done for clients. I'm just going to talk about a little bit of our experiences there. So first of all, why am I here? Let's step back in time a little bit. 1995, a young man, myself, was hired by a company called Blue World Communications in Washington State. Prior to that, I had worked at a university running the Student Computer Network, which was all Mac-based for the most part. Had a hand in getting that small college on the internet, which was a great experience. Also did some automation there on the campus, and started using a piece of software called Userland Frontier. Anybody ever heard of Frontier? So I got hired by Blue World Communications to do internet services using Frontier on the Mac OS with FileMaker Pro. So this was our stack. And I ask myself now, why? Why were we doing that? Anybody got an answer? I don't. No, really the reality was we knew Macs. We loved our Macs. Macs were great. Even though it was classic Mac OS, cooperatively multitasked Mac OS. So that was good times. Did a lot of client projects, again, using Frontier primarily. Anybody ever used FileMaker before? Yep. It's not a great server database at all. So again, why were we doing this? Well, it's what we knew, and that's what I was ordered to do, so I did it. Did again client projects, did some fun things, wrote some C extensions to make it quicker, so things were pretty fast for the times, and again running on Macs. Some of the Macs we hosted locally on our network over our ADSL connection. Others we co-located at hosting companies that would facilitate our crazy Macs. And some companies even carved out a niche for themselves, allowing people to host their Macs of various kinds at their data centers. Skip ahead a year. 1996, along comes Lasso. Lasso was originally in its 1.0 incarnation called NetFM, written by a guy named Vince. And it was coded in C. So that made it quite a bit faster than what we were using. Frontier was, a very dynamic language, very cool language. If you're interested in programming languages, it had its own built-in object database, which made it kind of unique, even still today, I believe. It was written by Dave Weiner, who, if you ask him, he invented the blog. And so Lasso came along, and we teamed up. Blue World teamed up with Vince. Vince came on. We finished the product into a 1.0, renamed it Lasso. I came up with that name. And that's what we use. So now our stack here, by that time we'd moved to FileMaker 3, is still Lasso, WebStar, and still on the Mac OS. So Lasso was a CGI. It was written in C. Think of it as a templating language. Think of it as mustache, but like a sloppy mustache, without any of the nice restrictions that keep things clean. For some historical context, so we're talking 1996 here, 1995, MySQL, PHP, and Apache all premiered in their initial releases. So that's a good way of saying there really weren't a lot of great alternatives to what we were doing at the time. I mean, those were all 1.0s. We were a 1.0. None of those really ran on Mac OS, the classic Mac, which is what we were dead set on serving on. So that just gives some historical context. Nowadays, you kids have it so easy. There are so many great options in programming languages, databases, even operating systems to host on. It wasn't like that back then. Skipping ahead a tiny little bit, we had continued to do client projects using Lasso. And in 1997, Lasso was sold to Claris. If you don't know what Claris was, who it was, Claris was the software company that Apple spun off in one of their restructurings. So they moved all of their Mac, the Mac Paint, Mac stuff, over to Claris. Claris acquired what eventually they renamed to FileMaker. So Claris was interested in bundling Lasso into FileMaker. So Blue World made a deal with Claris, got some money. Claris took Lasso. Vince went over, helped them integrate it. They renamed it to CDML, which is Claris Dynamic Markup Language. Doesn't have quite the same ring as Lasso, and they embedded it in FileMaker. So in the FileMaker database, which again is still not a great server database, had the built-in templating language, so you could put your databases on the web. And a lot of people were doing this because they used FileMaker internally to run their business. And as the internet was becoming more and more prevalent in our daily lives, these companies wanted to put parts, some or all of their internal applications on the web for their employees to use, et cetera, and people still do that today. Claris eventually divested themselves of all software except FileMaker and renamed themselves to FileMaker Inc. So sold is in quotation marks because it was more of a licensing deal. We did sell Lasso to Claris, and then they licensed it back to us. So just due to the way the deal was structured, we were given the opportunity to continue developing Lasso, and so we did. By 1999, one part that's important to mention is immediately after this deal concluded, and I honestly don't know how much money was involved. Immediately after this deal was concluded, the guy who owned Blue World and Vince had a falling out, like almost immediately. Vince went on to do a Cold Fusion clone named Blue Dragon. And I became the lead developer at this point. And this will come around to Swift eventually, pretty soon. So around 1999, we had a built-in HTTP server, mainly for development purposes. We still were a CGI. We worked with WebStar at that point. We concentrated on database connectors, so we weren't really tied to FileMaker anymore. So we added database connectors for a variety of databases that aren't really around anymore, and some that are. We had a variety of markup syntaxes, so people could use their own sort of idea of what the best templating was, one of which was server-side JavaScript in 1999, which is interesting. It wasn't what you get from Node these days, but it was still there. It was very hard to maintain and almost impossible to get a JavaScript engine to compile cleanly. By 2000, we released a version for OS X, which was brand new hotness and wasn't actually released until 2001. But that was our first kind of move towards Linux or Unix. And by 2002, we went cross-platform with Windows, Linux version, and that was version 5 of Lasso. And that's where Lasso really sort of became a programming language in its own right, more than just a markup templating language. We also had some popular products, Lasso Studio, which worked with Dreamweaver, Go Live, which just gave you authoring abilities. Moving up, 2010, Lasso continued to evolve and grow. Lasso 9 was the largest endeavor that we had taken. And as Lasso grew and matured, various pieces were rewritten, upgraded, rewrite the parser 1 year, speed things up here and there another year. Lasso 9 was released in 2010. I believe I started it in 2006. It took a really long time. Actually kind of wrote it twice, but I don't like to tell my employers that. Lasso 9 was built on LLVM, and it was LLVM 3.2 at the time. It was a fantastic tool. I'm sure you're all familiar with what it is. It featured ahead of time and just-in-time compilation. It had a nice multi-threading model, which prevented you from doing crazy things like trampling over memory from other threads. Used actors. It was trait-based, and if you're not familiar with traits, they're very, very similar to protocols. It had, at the core of the language, an asynchronous I/O system, which was hidden from the user. So when you make networking calls, if there's any sort of blocking, you don't have to supply a callback or anything, because Lasso's in control of the language. It can immediately swap out your thread to some other waiting thread, if there are any, and as soon as your I/O completes, you're back into your function call completes, and you continue on. So there was no concept of the kind of callback, Hades that you can get when you're using asynchronous function calls with callbacks. Also featured multiple dispatch, and that's where kind of the just-in-time compilation went in. A lot of the core was written to itself because it was starting to become kind of a competent language that I wanted to use to write solutions for the internet. Did a lot of study on existing languages and kind of pulled out the best parts of each and tweaked the syntax to make it cleaner and nicer. But it is very difficult, and keep in mind, Lasso is a closed source, proprietary programming language that was commercial. We sold it for money. We had a good number of customers. They ran on Windows. I mean, still people serving on Macs. By that time, we had Xserves and OS X, so it was a little bit more reasonable. But selling a proprietary programming language, even 8 years ago, is very, very hard, and I don't recommend it. Don't do it. So we're running out of money. It's difficult. We still have clients, but it's not enough to support. It's enough to support maybe one full-time developer and maybe another guy, but we're struggling a little bit, and a lengthy development time didn't help. So Treefrog, who I work for now, and I worked for since 2010, they purchased Lasso. The reason they did that is because they used it internally for a wide variety of services. They had their own products built on it. Leap is their CMS, or content management system. And it's just a variety of things, time tracking, all this kind of stuff. They used it. And Sean had been my boss, had been a longtime Lasso developer. And he relates that when he decided to choose Lasso, he flipped a coin between Lasso and I think it was Tango at the time, and it came up Lasso, heads, assume it's heads. So I came on and started working for Treefrog. They purchased Lasso. I had kind of started phasing out a little bit. I was a bit burnt. I had worked, super hard to get this working, and I was quite pleased with it. It was hit and miss with the customers. They don't like change. We tried to keep a lot of backwards compatibility, which is kind of what we've tried to do ever since the beginning. So I came on doing maintenance work on Lasso, but more importantly, iOS development eventually, not necessarily in 2010. But I also work on R&D and other special projects. It's working on a programming language like Lasso. You get to dabble in many, many different disciplines in computer science. So I think that gave me a good perspective on how to get basically anything that would be thrown at me done. So 2014, Swift is released, and I immediately said this feels very similar to what I had been kind of going for with Lasso, but with cleaned up syntax and none of the baggage and far fewer features. But it still felt really nice. But it's a client-side language, so who really cares? We use it for iOS. And then in 2015, June, Swift open source was announced, and more importantly, it was announced that it was going to run on Linux as well, which is the only thing that matters. So in July, I started to work on what was, in my mind at least, Lasso 10. It was a new take on it. We were going to bring over kind of what we had as far as the framework and some of the core functionalities and bring it to Swift if possible. And this was the kind of project that I worked on for a week or so before I told anybody, just because I wanted to know that it was possible. And so because of the experience writing Lasso and because it was cross-platform, I kind of already knew the bits that would need special handling, the bits that probably wouldn't work on Linux. And I sort of knew some of that even before it was available on Linux. And for the most part, we were correct. So this kind of gave us a head start, I guess, on getting something out before it was practical or feasible to actually have such a thing. So what we came up with, it was eventually renamed. Don't blame me for the name. I didn't pick it. But you got to call it something, so might as well call it perfect. So we don't really think of perfect as a framework with a capital F. To us, it's more of a toolkit. And in the workshop the other day, someone made a comment that compared to some of the other frameworks, it doesn't seem very opinionated, and I think that's a good take. It doesn't enforce a lot of structure on you. It gives you enough to build a structure that fits your opinion around it, and I think we'll all agree that it's nice to have options, and we don't want just one framework, no matter how awesome it is. So this is the toolkit that we made, that we wanted to use, and that we were kind of, at least in our minds, segueing from Lasso to. And one of the problems is it's really hard to maintain a programming language. It takes a team of people. You can't just have one, maybe two people driving themselves into the ground trying to get stuff done. So like I said, I was a little bit burnt out on stuff, but still, coding every day. I love to code every day. And so this is what we came up with. And we were able, like I mentioned, we were able to bring in some of our cross-platform code for threading and networking. We even had implementations for IOCP, or IO completion. Yes. And a lot of the database connectors. So we already had experience of using those APIs in a wide variety of circumstances. And so our current version of Perfect, and you have the GitHub link down there, all of our packages, for the most part, all of our packages are at version 3. So I'm going to go into a little bit more detail of what Perfect has to offer. And the way I'm going to do that is by introducing our core team, 3 of us, and talk about the different things that we've brought to the project. And so that'll give you an idea of what Perfect has to offer. So that's me. I work primarily on the server core. I did our support for TLS. We do use OpenSSL at this point. I know a lot of people have moved from it, but we're still on it. I did the initial work on the threading model, and it's important to remember that when we first did our first release, libdispatch really didn't work on Linux at all, so we did our own custom pthreads implementation. I worked on the networking layer, and we've had, we felt very strongly, even from the beginning, that we should do an asynchronous model for the networking. So our net package is, it's asynchronous. You can manually switch it, but there's no reason to do that. I worked on the HTTP server and the HTTP2 server, which we still consider a little cutting edge. I don't know if anybody's ever used it in production. But it's optional, and you can turn it on if you just add a switch. I did most of the database connectors. We support Postgres, MySQL, SQLite for prototyping, Redis. We support more, but another person did those, and I'll get to those. We still support FileMaker, even today. Did so much work on the XML processing, I hate to throw it away. It's not really used anymore, but we did launch originally with fast CGI support, so you could use it with Nginx or Apache if you wanted. I think it's kind of languished a little bit. I worked on the routing. We, ever since Swift 4, we have a codable-based routing, whereby your handler function accepts a parameter that was decoded from the request and returns some sort of value that is in turn codable and able to be squirted out to the client. I worked on our CRUD. It's an ORM. It does CRUD. It's called CRUD. It's built on Swift 4, so it has codables and key paths from the ground up. And there was some talk about ORMs earlier and the differences. CRUD, at least now in its current incarnation, is built on the philosophy that you can swap out the database underneath it. And you can always go to direct SQL if you want to, but if you're using the expressions and the standard built-in functions for doing joins and stuff like that, it doesn't matter which database you use. In fact, I just copy and paste all of the test cases from one data source to the other, and they just work pretty well. Also worked on the APNS support, so we do support iOS notifications. We don't have anything supporting notifications for Androids at this point. Worked on the crypto module, so there's, again, it's OpenSSL. We expose as much of OpenSSL under nice, neat APIs as possible, including JSON Web Tokens and a variety of encodings, base64, hex encoding, these kind of tools that everybody will need from time to time. And since the original release, we had support for mustache templating. And that's really the only kind of templating that we support at this point. You could bring in your own package if you wanted, but the only one that we maintain and released is Mustache. I also did the coding on Perfect Assistant. Perfect Assistant is a macOS-based application. It'll work with any SPM-based project. And its main features, in my mind, is that it handles Linux Docker builds for you, including crawling through all of your dependency packages and adding any apt dependencies that you need for your Linux. So you can click a button and you can get instant feedback on any Linux compilation errors. You can click another button and do a deployment build of your Swift app on your Mac in Docker, ready to deploy. The other major feature that it has is it lets you pretty easily deploy to a variety of services. I think the most furthest along the system that we support is CloudFormation. So you can drag your Swift projects into the deployment configuration and pick your instance size and whether or not you want SSH access enabled and from where, all the kind of standard stuff that you would expect. But we also have a CloudFormation package which allows your services to kind of discover each other. And you can drag in a Postgres or a MySQL or a Redis installation and be able to determine easily username, passwords, port kind of stuff in your application. Jono Guthrie is from New Zealand, but he lives in Canada now too. He's worked on a variety of applications. So we have a few applications that they're written in Perfect and can be used either standalone or with Perfect, most notably an authentication server, which supports OAuth 2 plus local authentication with storing your own users in your own database. He did a Stripe package pretty recently. He's done a variety of servers for us. He's done a stats server, which we use internally, a few other things that we use internally for ourselves. He has his own ORM called Storm, which is in his own repository. Works with Postgres, MySQL, SQLite, Mongo, and Couch. And he also did the Couch connector. I think about it, I did the Mongo. Here we have Rocky. He's from China. He also lives in Canada. He's done an excellent job on our Chinese documentation, translations, and support on the Slack channel. I don't know what he's saying, but people seem to like it. In fact, we have a lot of our users, just from my perception of it, are from China. So again, he's worked really hard to keep his finger on the pulse there because none of us speak Chinese, and a lot of the Chinese folks using Perfect don't seem to speak a lot of English. So his job on the translations of documentation have just been invaluable. He comes from a machine learning kind of AI background, and so he was real keen to do a few big data and AI-related packages, and these are mostly wrappers around existing C libraries. TensorFlow, he's done LDAP, Kafka, Hadoop, Mosquito, as well as Python bindings, which he was really excited about. And these are things that, again, he's either wanted to use on his own or we've needed for some sort of client project or another. So that's kind of why we have this sort of random-looking set of packages. There was nothing available. We needed it, or maybe wanted it in some cases, and so we added it. And we just covered adding C libraries to Swift, and Swift has excellent integration for C. So bring them in, and we did. Next we have Sean Stevens. He owns Treefrog and hired me and everybody else. He's our fearless leader, and he makes it all possible. I don't think he directly signs checks, but he hired the person who signs the checks. So that's exciting. So that's the team. 3 developers, 1 leader, facilitator, great guy to bounce ideas off. He's got his head in the clouds all the time, but his feet on the ground. What do we use server-side.swift for? I put a spoiler right there. We use it for mobile backends, almost exclusively. We do have a few applications running that are not mobile. Most of them are used internally. We have kind of a log aggregator, and it will let you perform queries on the data, and I believe it stores it in Mongo. Lets you do queries on the data and make nice, pretty charts and things like that. But for the most part, mobile backends. Here's talk about a few of the projects we've worked on. Help Wanted is, think of a Tinder for job seekers and employers. We have Swift handling authentication, regular API calls for the app itself, as well as chat. It also does some processing of geolocation information, although we try and have the database do as much of that as possible. For the most part, the database that we use on all of these is Postgres. In fact, aside from the stats server, we use Postgres for everything. Smirky. Smirky is a video chat app, which, while you're chatting with someone, it will send their face off to an emotion recognition API, which we did not write. That's a third-party API, and will tell you what the person is feeling. I always thought it would be nice for people with kind of social disabilities, but they wanted to make it in kind of a fun app for teenagers. We had to do authentication, notifications, API, regular API calls for the app, as well as a signaling server for WebRTC. So this helps facilitate the handshake between the 2 participants of the call. Anybody worked with WebRTC before? I'm sure quite a few have. It has this concept of trying to get around network address translation and things like that, so you can. This is important when you're dealing with mobile, because obviously you can't just connect to another person's mobile device. You need something to facilitate. So we did our Swift server as a signaling server, it's called, and this just does the handshaking. It comes up with agreements on how these 2 parties should talk to each other, and then sends it off to what's called a turn server, which we didn't write. And you chat. A few others, UMunch, Butte, Reset Zone. For the most part, we have Perfect Server doing authentication and regular API calls. Butte app is for working with and scheduling hair appointments. And I know that Rocky was working on some AI add-ons for that to kind of tell you, if you like this haircut, this haircut, this haircut, maybe you should go to this person, because they have all these people who have come out looking more or less the way you like. I'm not sure if that ever has gone live yet, but he was working on that. Another internal, well, not internal, this is external, our assistant server. It's basically just a file server, but it handles upgrades for Perfect Assistant, which uses Sparkle, which is a great library for updating your macOS apps. In addition, the stats server, I've already talked about that. Cubic. Now we're to what originally, when I agreed to come speak at this fantastic conference, I expected to spend a bunch more time on Cubic, and I left one in my backpack there. These are little Wi-Fi enabled devices. They're Internet of Things things. They're 2.5 centimeters. They pack in the battery, chip. They use the ESP number chip, which is pretty popular these days. So what they do is they combine a lot of sensors into one tiny little package with a focus on long battery life. Depending on how you've set it, the battery could last for 2 weeks, maybe a little bit more. They have a little USB charge port. They have little blinky lights inside to let you know what's happening. So they sense temperature and movement, as well as light, which is kind of hard to do inside of an enclosure, as well as humidity. So what we've done is pack a bunch of sensors onto one little board, and when people buy them, they're designed to be relatively inexpensive. I think the target was maybe $20. And so you would buy one that does temperature, and then you'd buy one that does movement and lets you graph those. We've, all along, the intent is to make the data open. So that means that in addition to being able to get your data from our servers, which has been collecting it, you can also self-host all of the applications, and all the applications are written in Swift. There's a cubic with some scale, and there's the app there, which does a lot of charting. You can group your cubics. You can attach whatever garish color you want, name them. You can share them. You can see they have a QR code on the top. So you say, I want to register a new BIC, and then you can point it at it, and it's like, this BIC is already owned by somebody, but it's open, you can share it. So you can share the data, or you can lock a BIC so nobody else can scan it. Or if nobody owns the BIC, then you can say, I want to register this for myself. I need to charge my phone. So this cubic project has been going on for quite a while. I mean, there's a lot of design involved, much of which I'm not involved in. I don't do hardware. But I do the software stuff. So we kind of recoded some of the stuff, kind of re-architected a little bit. That's what I'm looking for. After Swift 4 was released. And we've always been excited about the opportunity. Since we do a lot of iOS work, we've been excited about the opportunity to share code amongst iOS devices and the server. And I think with Swift 4, and particularly with codables, this really came to fruition. So what we have is a set of packages. They are separate, distinct packages, which they don't really have any code in them at all, but they do have the codables. So they just define the base API for the whole system. All the database structure, it's built on our CRUD package. And these can be shared. There's a couple of them. We have one for authentication, which defines the database structure for that stuff, and then one for just things to represent a report by a BIC. So we have a few different pieces. You would consider these microservices. For the most part, all the stuff we do would be considered microservices, I believe. Authentication, we have the collector, which speaks a proprietary protocol that the BICs report to. And it's just designed to be very lightweight. And so there's not a lot of processing on the BIC itself because we want its batteries to last a long time, because nobody wants to go searching for this tiny little square and charging it every other day. And it also handles over-the-air firmware updates. So a BIC can check in, and it'll give its report, this is the temperature, all this kind of stuff. And the server will look and say, oh, you're using this old firmware, so why don't you do an update? And then it'll feed it the update, and the BIC will do the over-the-air update, and now it's got the new version. We also have a server for regular API calls. There's all the little things you would do in the app, like grouping your BICs, making the graphs, basically, giving you the data for the graphs. And then we have a link director, which handles handles what happens when you scan a BIC. It gives you a certain URL, and it can direct the user to either inside the app or to a web page where they can click it to get more information about what the heck this is. And this whole system is built on Postgres. We use Redis for message passing, message handling, things like that. So if you want to look at the code, it's all open source. I mean, the firmware for the BICs aren't, but that's not really Swift, so nobody cares about that. The BICs are not available yet. They're, I don't want to say hung up, but they're still in manufacturing limbo. And we were hoping to have some BICs and we could, pelt you in the audience with them. But thankfully, or unfortunately, we can't do that. So, like I mentioned, we did want the data to be open, and as part of the proof of concept, I was writing a little iOS app that took the same data that the BICs were sending to make the nice little temperature chart and took it in a completely different direction. So when you scan a BIC, you're taming it. You scan in the QR code, and it will create a little avatar for your BIC and generate some random stats and present them in this app. So you've got your BICs that you own, you've got friend BICs, and this is an ARKit-based application. So we can see here, I've pointed my phone at these QR codes, and we've seen their little avatars pop up, and eventually we'll make them fight. So that'll be cool. But the point is, you've got to keep your BIC healthy. You've got to keep it in the right temperature range. You can't let the battery get too low. If you do, its health will kind of drop, and it won't be as effective when you go to battle. And this is a demo app. It's made to kind of be a proof of concept of what we have driving us in our design of the architecture for the QBIC, is that the data is open. We don't know what people are going to do with it. We're collecting it. The servers are open. We don't have to collect it. Maybe you want to collect it. Again, just open is the point. And finally, this is the last slide here. And it has nothing to do with what we have used Swift for, but it's about what we're going to use Swift for. Basically, as soon as I get back home, we've gotten a couple, well, we've gotten one for sure, and another one is just kind of pending for us to finish. The first one, a couple grants from the Canadian government. The first one, well, the point behind these is that we get access to a data center that we can use ourselves with some really nice hardware and a nice system for provisioning VMs. And what we're going to do is try and do some fair tests between frameworks written in Swift, Go, Java, Ruby, Python. So we're going to be punishing all the Swift frameworks, and our goal is to be able to break stuff, like just slam it with traffic and get metrics as we scale up on real hardware, not a VM. And we're also going to, and I'm real curious about this myself, we're going to do a version of Perfect with Swift and IO, and just see how that compares. We already have an asynchronous engine. It's pretty low level. We have our own KQ and ePOL implementations or usages in there. So I'm curious myself to see whether Swift and IO brings any sort of benefit over something that's more of a custom solution. And the next grant, which we're probably going to get, and it's just paperwork, we're going to be testing the scaling of the QBIC infrastructure. So, does our infrastructure, our Swift-based infrastructure, scale to millions of devices, all sending reports at random times, and users doing user things that they do? Again, all on a real hardware and on a private network, so we know that there's no interference from other things. That's it. Thank you very much.